Good afternoon again. I'm back for the most boring 3 minutes of your life. The next presentation is on Security Tools Integration Framework, or STIF. So listen to Fyodor and Mida tell you how to get stiffed. Fyodor is a security hobbyist and quite a happy programmer, as you can see, with a few years spent in business objectives and the security service delivery field. These years, however, aren't completely wasted. Fyodor has been contributing his spare time to a few open and closed source projects that attracted limited use among non-business oriented computer society. He has a background in systems administration, programming, and holds an engineering degree in software engineering. And he would like you to know that Fyodor is not the Nmap Fyodor. Mida, on the other hand, is a freelance security researcher and has obtained his Bachelor of Science in Software Engineering from AUK, Kazakhstan. I got that right? And is at an early stage of getting to know what real security industry is. For the past 2 years, he's been involved in research and development of Xprobe 2 Active OS fingerprinting tool, and some of his personal interests include network reconnaissance, information gathering techniques, and applications of distributed computing in information security tools. His senior project was titled Multi-Threaded Distributed Platform for IS Tools. And without further ado, Fyodor and Mida, big hand for them, please.
It's second one. First one. No. Slide number 1.
Yeah, thanks for coming, by the way. Basically, what we're gonna present is our result of our efforts on creating the STIF. STIF is a framework which we try to design to automate part of the job that we do every day, and part of the fun stuff that we do every day, but once you do it once in a while it becomes boring. So basically we try to automate the most routine tasks that you perform whenever you try to get into other network, basically. Before we start, I would like to mention that we want to dedicate this work and this presentation to victims of the security industry, which I believe most of our are. Yeah, shall we start? Yeah!
Thank you for your attention.
Can we go to serious slide?
Sure, please.
Sorry, slide. Alright. First we would like to introduce the reasons why we think hacking automation is necessary in everyday life, and why we believe what we're trying to develop might be useful to the people. Basically, any attempt of getting into any target network starts with regular information gathering, port scanning, getting banners, getting software, trying to get map most common vulnerabilities, use your scripts. And it's fun when you do it first time, it's fun when you do it second time, but it gets boring when you do it for a year, every week, in a month. So we believe it will save a lot of time if you have some sort of environment where you have point and click and it does everything for you. Another thing, the same framework, when you testify automated, when you test intrusion detection system, for example, for the moment the most advanced testers, what they do, they just like replay the traffic on the network, and it doesn't mean it's a real attack. Using a framework like this, you can actually script out different tests for intrusion detection systems, and you can just like replay them over and over using like real life tools. Another thing, you can. The framework itself is actually it's based on the artificial intelligence, like algorithm sort of thing. So if you're trying to develop like independent intelligent agent that will do like network discovery, network research, you can actually take the whole framework and put it as a part of the agent, and it like will do like the basic network reconnaissance for you. Yeah, and another thing, like no matter like how much time you do the same stuff, there will always, if you do it by hand, there is always a chance that there would be like a human error factor. There would be always something that you will miss. By designing like automated system that analyze the facts regarding the target network, we believe we can mitigate the human error factor, so no facts regarding the target network will be missed. And aside from regular like technical reasons why we want to do this, there are also like InfoSec business influenced reasons. One of them is in a common security company, your boss wants you to do like a pen test a week, and there is no way you can actually do it and keep doing like fun stuff. So what you do, you use the framework, and like you spend the time for whatever you want to do. Like, so your system will be like hacking the stuff while you can like go, you can sleep, you can drink, whatever. Yeah. So
why do we need to integrate several tools? There are several reasons actually. First of all, there are numerous security tools available written in different languages that produce the results in different formats, and there is really no facility to actually analyze and correlate all the data that is produced by these tools. Also, we need integration because really like a repetitive manual scanning of the networks can be a nightmare, because you have to do the same thing all over again. You could also integrate the stiff framework into the self-propagating agents, which would basically do the network information gathering and scanning.
Yeah, basically like the integration is like you take different from like different tools, you convert it to like a common format, and then you can manage this data. And this data is like could be vulnerability data or just information data regarding the target network, hosts, IP addresses, ports, services, software running, anything.
For example, like the regular penetration test, the way it goes is that first security analyst runs a set of network discovery and mapping tools such as Nmap or Xprobe or something. Then after that, after you got the results from the tools, you need to manually review them and see what services are on, what applications are running, and based on that you will launch some like protocol or application specific tools. But this is something you have to do all over again, and we feel that this should be automated.
Yeah, there's basically like a non-productive usage of time when you have to do like the thing that your computer can do. So we're trying to like solve this problem.
So why don't we let machine do the
work which like human is not supposed to do? That's what computers are for, after all. Yeah, possible solutions that like could come in mind. You can actually write like shell scripts for the whole thing, but like I was doing this before and end up like having a few hundred shell scripts in different folders, and after I use them, like no one knows what the script does. No one knows what it could be used for unless you look at the script content. It gets messy. The other thing, you can use like security scanners. That's what like most of the companies do right now when they do like penetration testing. But a scanner is just like automated system. It only does what programmer makes it to do. There is no way to control what it does, and there is no way to direct it. And even if the user who is using the scanner is smarter than the scanner itself, there is no way he can make the result more smarter. There are very few like exploit toolkits recently. One of them is Metasploit, I think, wonderful toolkit. It basically puts a few exploits together, but it's still, you have to know when and what for you have to run it for. And that's not exactly what we want. We still want to make the system to run it like by its own. Most of the things that a computer can do, we want it to do. Or like the last solution, which is like quite common in a few companies, you can hire like a room of monkeys, and they will run everything for you. And monkeys cost cheap. Yeah. Or like the other solution that we would like to introduce right now is please meet Steve. Is an automated monkey for your networking needs. Basically, once we decided we need a tool like this, we put up a few design goals for the tool. One is if we want to integrate new tools in our system, we want it to be as simple as possible. We don't want to like hack any new code to run a new tool. Like we don't want to write any new wrapper for the tool. We don't want to like develop a plugin which will like use the source code from the tool. It basically should be as easy as hacking a shell script at most. Another thing is a scanner, basically like a regular security scanner, what it does, it just scans like according to the programmer designed it for. And what we wanted to do, we want to have ability so you can actually script out the attacking scenario. So sometimes you want to start from that, sometimes you want to start from the other point. Sometimes you just want to scan like web services and you don't care about anything else. Sometimes you want to scan SMTP. And then the last design goal actually was, we believe that analyst who is using the scanner or who is using the tool is actually smarter than the tool itself. No matter like how much like data you put in your tool, a person usually, if he knows what he is doing, he would be able to find some stuff that tool would not be able to find. So what we want to do is actually to have an ability for a person to interact into the like tool execution flow, interact with the tool execution flow, so he can affect or direct the tool to go the way. A model which takes care of the data format unification and the data integration into the framework. The second model which we design is an inference engine. Inference engine is actually the brain of the system. Inference engine is using like rule-based is using like a pre-configured rule base to execute the scan or execute the attack. Inference engine also assists as a media for data exchange. So it takes the data from one tool, it converts it to the format that other tool wants to accept, and then it runs the other tool. And then again it parses like it's using like a pre-configured rule base to execute the scan or execute the attack. Inference engine also assists as a media for data exchange. So it takes the data from one to accept, and then it runs the other tool. And then again it parses out the output from the other tool, it brings back to the knowledge base of the system, then converts it, runs the other tool. And we also have unification components. These components, they're actually taking care of unified process execution and the data import. So they actually act as a layer when all you have to do, you just have to tell tool, I want to run this script this way, give it like this parameter, and this parameter, and like I give the host name, I give port name, I give the application banner, or I give the like platform name, whatever. And also this model is responsible for importing the data into the inference system itself, basically taking like all the formats like from different tools and converting into a simple form of like stiff message.
What is stiff message? As was said previously, the problem is that most of the tools have their own format of data that they gathered and present to you in its own format. The problem is that it's hard to integrate things when you do not have a unified format. So we have developed this unified format, and we, for now, created the following types of stiff messages. That is a target message. That's the message that is sent when you add new target, which is IP address of the host you want to scan. The next is a port. Port is a message from any port scanner that would report the state, protocol, and the address and number of port. Platform, which would be like OS fingerprinting tools that would return the platform that the application runs on. Application itself is a message that is sent when the application is fingerprinting. That is, if you detect Apache web server on the TCP port. And URL file location, which is a message that would be sent by web application enumeration tools, which would search for maybe vulnerable CGI scripts or something like that. And now we would like to show you the sample stiff message.
Yeah, just like a small comment. Basically, a stiff message is just a set of notification messages that notify the system that a certain type of data arrives. If the type of data that we designed is not enough, you can extend it. Well, to extend it, you actually have to hack the code. But I think we covered most of the data that you might came across during the routine of remote network intrusion, basically. Okay.
So this is the format represented in XML. We see the stiff message opening tag, which has a created timestamp attribute. Then this is a sample message from the port scanner, for example Nmap, which was launched as a like scene scan with version scanning also enabled. So it says that it has detected on the port 80, it has detected that TCP port 80 is open on target 192.168.1.1, and it was running like HTTPS protocol, for example, and the application is Apache 1327. So yeah, that's how you would represent a message about the port from the port scanner.
Yeah, and in the rule base we actually implement like regular expressions. So when you match the incoming data, you can just say that you're looking for like application. It could be Apache, and you can put like asterisk here, so it will be like any Apache. Or you can say you're looking for application like Apache asterisk plus port 80, or you can say you're just looking for port HTTPS and any application, so you can just run like scanner against the web application itself. Basically, yeah, I just covered the inference engine like shortly, just like to go into more details. Like the primary like functions of the inference engine that we design is to assist the data exchange between the tools, and it provides also like mechanism for data aggregation and correlation. So you can actually design your like a model which will take the whole data and lock it into database, like store into text file, whatever. It also maintains like eternal knowledge base, like basically a base of facts regarding the target network. And it maintains the execution flow using prescripted rules, basically like rule bases. Yeah, and the unification components, I covered them already. Basically, there's the diagram which explains how the whole thing glues together. So what we have is rule base. The rule base is like created manually. During the demo, we'll show what the like a simple like rule base could look like. And rule base will consist of rules. We have like the core of the inference engine, which is like which is performing like role matching against the knowledge base, like facts in the knowledge base. Knowledge base itself is just a base that keeps every fact regarding target network, including like, and it's indexed by IP address, and all the facts are represented in form of like stiff message, like you just in the serialized form of like a simple stiff message. Knowledge base communicates with the unified data import, so whenever like tools get executed, the knowledge base can have like new facts added, or actually tool can say, oh, that fact was wrong. So if it returns the message that will say that fact was wrong, it also can be removed. Rule engine, once it searches through the rule base, once it finds the facts that match the facts defined in the rule base, it will trigger the execution. It could happen that there would be a few rules matched by the same fact, so it has some conflict resolution mechanism. Right now it's just like if it finds like a few rules, it will pick up one, and it triggers the rule execution. The rule execution executes the external tool through generic exec. Generic exec is just a module that have another configuration file for different execution patterns. So in a rule you just say, I want to execute this pattern, or I want to execute this pattern. You don't have to put all this command line switches, the like pipes, scripts, whatever. You just say, I want to execute the nmap sync scan, and generic exec will know based on its configuration file that nmap sync scan is actually nmap minus ss la la la. Generic exec, once it executes the tool, it parses out the output data and converts it into a unified form and brings it back to the knowledge base. That's how the whole thing works. Yeah, and right now I would like to, if there are like any questions regarding system, we can ask them, so we can clarify before we can actually show how it works. If there are any questions, I would like to switch the monitor.
If you were confused a bit, yeah, it will be clear now once you see the.
Yeah, we'll show you like how the tool works right now.
So basically we have two configuration files, which are exec.xml and rules.xml. Rules.xml defines basically the scenarios. Each rule consists of two parts. First part is a prerequisite, which is a condition that has to be met, and the second part is the comments that should be executed. As you can see, for example, the first rule name scan. It has a condition which says that it should have a stiff target message with any IP address. That's a regular expression here that would match any IP address. And the stiff action that should be taken is to execute xprobe and nmap syn. Remember those two, because we will see how they are described in the exec.xml file. So this way you can script, you can basically create any scenario. So the next rule is the web scan, and the condition is that you're interested in any port in state open and the protocol TCP, which should have the application level protocol HTTP. This would match HTTPS also. Yeah, and the action for this for the condition, it would be to execute nicto and HTTP brute, which are the commands. And this way you can actually, this is really flexible, and you can actually do anything. You could simply execute exploits as soon as you have the target IP address, just without scanning anything and wasting time. Yeah, and you can actually describe quite quite a flexible scenarios. Now if we look at the exec XML, which describes the names that you saw in the exec, between the exec tags, we have the special characters, which is %h, which stands for host, and this would be substituted to the IP address. The P would be substituted for the protocol, which is the application level protocol. N would get substituted to the port number, U for the user ID, S for the password, and capital F would be for the temporary file. You will see now why do we need that. With our stiff message, you can actually describe the data that can be produced by password brute forcers, dictionary attackers like Hydra and things. So yeah, that's why we have the user and password. So as you saw, it says to execute nmap scene. You see the command line, all the command line switches here, and we have %f. Basically, in this case, %f is needed for us to convert the nmap format to the stiff message format, and that's what we do. We first execute nmap and ask it to save all the XML output to the file, and then our converter parses this file and adds all the ports information into our knowledge base. And this way you can actually describe any command you would like to execute, and all the command line switches will be here. So we will show you how it works actually. To start it, you need to add a target. So we add a target, which would be localhost, which has one port open, HTTP. So as you see, it's now matched two rules. Yeah, I'll scroll up. It starts off by, it says that the new message, new factor path, which is target, is and the IP address, and according to the rules, it should execute xprop2 and nmap. You see that nmap was executed, and our converter also was executed. And after converter executed, it added several new facts about the port information, which is, it said that for example, TCP port 25 is in state closed, and if we look for the for this message, which is a message about the port number 80, which is in state open, application protocol is HTTP, and application is Apache HTTPD, and the version, basically the full banner. And based on our rules, we have that once we have HTTP protocol, we need to execute HTTP enumeration tools. And thus, you see that the Nikto is executed here. And HTTP brute also executed here. And as you can see, the targets are given, the %h is substituted for the IP address. So yeah. So that's how it works, and the protocol also. And this way, the problem why we didn't integrate a lot of tools is that because really the format of each tool is separate. So we really hope that after that presentation, maybe tool writers will, convert to the stiff message. This way, you could easily integrate any tool basically, and you do not need to recompile anything. You just describe the scenarios in the rules.xml file, which is quite flexible.
Yeah, also you can see very extensive logging here. That's we did specifically for the conference, just to demonstrate the eternal functionality of the system. So normally when executed the tool, it's not so verbose. And another part of the logic in a system, once the new facts added, they're supposed to be used by the system. If the facts are not being used by the system, they remain unused in a knowledge base stack. So with the command show, we can actually see which facts remain unused here. Yeah. In case if you see that your rule base actually had a problem, and some facts that you didn't expect to appear, they appeared, you can actually add new rules as the system goes, and reload the rules and make the the remaining like facts regarding the target system like match and execute as well. So if your system gets stuck or it doesn't know what to do, what you can do, you can add new facts that you find manually, or you can just add new rules and let the execution flow like go on. And another thing is like for any match that you've seen here, you can use regular expressions, the same as you use in Perl. So you have the whole like power of regular expressions to match any fact that is coming like from the result of the target network scan network reconnaissance.
Okay, if anyone has any questions about the execution or would like to see the rules,
Yeah, if you have like any questions regarding this demo part, like if you want to like ask some questions regarding the rules, or like you want us like to add, modify something and like demonstrate, you can ask now. Yep.
After a first run, obviously you discover some facts. Is the inference engine then able to sort of launch other probes or other tools?
Yes.
Yeah, that's actually what happened. If you scroll back here, we can see first, like when we add target, the first rule that will match is the scan rule, and it will execute nmap and xprobe. Nmap produce like a certain number of facts. Among those, HTTP port 80 was a protocol that it discovered, HTTP, and application name Apache. In a knowledge base, in a rule base, we actually have a rule. We actually have a rule that is saying if you find any HTTP protocol on any port, you will execute nicto and HTTP brute. That's actually what happened. Yep.
Obviously, once you've done that, you could sort of put it to the next level and launch exploits again.
Yeah, you can also chain exploits. You can even chain the propagation agent thing. So basically, once you chain the exploit and you parse the output from the exploit, and you just like use the regular expression to match that exploit succeeded, you can actually write another piece of code that will take the whole inference engine, upload it on that system, and launch it on that system. So you can actually have like a propagation system just linked as within the inference engine framework. Like you can go as far as you want, like as far as your fantasy like lets you, basically. Did I answer your question? Yeah. Right. Are there any other questions here? Okay, basically, once we got to this point, we were just like discussing the stuff in a plane, and we came up with a new idea that right now, like we have a rule-based like engine, but it has like strict execution like pattern, and the thing that which we are thinking of implementing next is sort of probability-based execution. So you can have like facts that each fact can have its weight, and each rule also can have its weight. So when you have like rules matched and the facts matched, for example, when you enter the fact from the keyboard, apparently you can like identify how like the probability that the fact you enter is true. When you have tools, you can say, yeah, this tool, like normally the probability of the result is like this. And what could happen after, you can have probability-based execution flow. So you can build like sort of Markov chains. Can we switch maybe monitor so I can show the diagram? Yeah, that's basically the diagram which demonstrates the idea. After you execute the scan, you get like certain results that can like say, oh, probably the system is Unix with a probability 0.1, or the system is Windows with a probability 0.2. So you have like different execution trees, and each execution tree will have its own like probability rank sort of thing. After the execution gets to the second level, you can actually even like make the system execute the execution threes like simultaneously. You will get like another score after like the tools for Windows will get executed, and they will like detect, if they detect an escape enterprise server, the probability of like from Unix it could be like 0.5, that usually an escape enterprise server will run on Unix system, and the probability of having like an escape enterprise server running on a Windows system could be 0.2. So you can actually build the probabilistic like execution threes, and you can have like you can have rule base that will get executed in like different directions simultaneously, but based on the probability that this this path will lead you to success, basically, like whatever your target is. But this stuff we haven't implemented yet. We're just like thinking of the theory.
And one more note is that execution application is multi-threaded, so it executes all the tools like simultaneously. So that's takes like the most performance out of the.
Yeah, well, what we have basically, we have a thread pool class that where you can define maximum number of the execution threads. So like if you can like add the task to the thread pool, and if you have more like say for example more than 100 tasks running, the remaining tasks, they will be queued up and they will be executed when the thread pool like flushes. Basically when it has like free space, then it gets executed. Yeah, if you have like any questions regarding the whole presentation, you can ask them now, or you can send us email. Like my email, the second email is meters. The big O in the middle is not always 0. Or you can check our website. I think like a few days after the conference, we'll put the whole source code and presentation online, so you can probably download from there. Yeah, and would like to say thank you for your attention, and yeah, cheers.
Sorry.
Yeah.
Usually I have two problems. First one is to suspend the tool. So during test you have to interrupt the pen test, and you also suspend the key.
Suspend like just using Control Z, yeah.
Shut down the box and after bring it back, and I continue to do that.
Basically, I think what you can do, you can dump the current knowledge base like of the facts, and once you start, you can just like reload it, and if you reload it, your system will be at the same execution state where it was. Like we don't talk about the secure tools you integrate, like all the secure tools they will have to run, but the knowledge base itself, if you reload it, it will be at the same state. Like if you look at the execution tree, it will get to the same point. So you can dump it, you can shut down it, then you can like bring it up, reload the knowledge base, and it will go on from that point. You can actually dump it, modify it, then reload it if you think that some of the facts were wrong. Like if you did like some manual testing and you discover that this fact is wrong, or this fact you want to correct, you can like fix it this way.
The second question, what about results?
For the results, if we have a look on the logging role, can you switch it back?
А что ты хочешь? У нас нету лога.
Есть лог в этом скане.
Нету.
Yeah, for the result logging, we have different type of actions that you can trigger. You can add fact, you can remove fact, you can execute. Apparently in this simple rule set we only define like execute and log. And what log will do, it will add the data into the logger. And for the logger you can define like any sort of logger. It could be like database logger. Right now it just logs it into the std out. But you can also like write everything into screen, into file, or you can like store database. You can even have like automatic report generator how you break the network. And when the logging takes place, in addition to the message you define, it will also store the fact that the execution flow matched. So you will have like the port number, host, whatever application, the result of the exploit execution, whatever, in the log as well.
Another way is to basically make your tool log to a file and then just report the file using the log element. Or you could actually convert your application or exploit to the stiff message format, and we have a special format to represent the attack results, and the whole output of the tool could be in the stiff message also stored, and it will be in the fact you could use it with a show, you could see it.
Yeah.
I was wondering, can you integrate FragDart?
Integrate what?
FragDart too.
So again, what was this?
FragDart? Fragmentation.
Frag route?
Yeah.
Oh, FragRoute, yeah, sure. FragRoute works the same way as Nmap, the same way as the xprop. What you do, you will open the exec XML, because you... Yeah, and basically what we did here is actually like just defining the execution line for Nmap, put all the command line switches, and we put the, like here we want to put the host, like the target host, which we want to execute the tool against when the rule matches. What you will do here, you'll just add like execute frag route, then you will like put the command line for frag route, you put the host where host should be. If you want like any port number, you put like the port number. For example, if frag route wants to do like any test regarding the open close TCP port, you can define that the rule should match open TCP port. Then you can like put the port number anywhere you want, and it will just work as any tool we just demonstrated. Did I answer your question? Cheers.
Sometimes you have fake results during a test. For example, during a scanning by map, your connection broke down, so you get fake results. Is it possible to double check? For example, to run twice.
You can add the same like fact like second time from the keyboard, from the console. Once you add it, the execution will also launch from that point where it matches this fact. So for example, if Nmap was triggered by execution by like fact target da 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 da, and you were not satisfied with the result, you will type target da 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 again at the console prompt, and you will like launch the whole execution point from that point. That's actually one of the design targets that we did, that you actually have to interact in the process of like tools execution. If you think something went wrong, you have to correct it like from the console.
Yeah, and the problem with like most of the scanners is that if someone admin modified the banner, for example, of the web server and says it's IIS instead of saying that it's Apache, for example, your security tool would basically launch the IIS specific tools, while with our system you can basically script out, you can launch Apache audit tools on IIS servers, no problem. You can do whatever you want.
Yeah, basically if you think like, if your like execution flow want to like run the IIS like attacks or IIS exploits, but you test it manually and you know it's Apache and you know its version, but the person just changed the banner, you add a fact manually that this IP address on this port is Apache, and the whole like inference engine will start execution flow from like the point where it matches this fact and go on like run the whole thing against that system. Yeah. So this way you can actually manually correct or like direct system like to execute the way you actually want it to. Yeah.
So basically, if I understand well, that tool is you're going to be able to use it like you define the target, you scan everything, what it finds, you exploit it, and then you automatically generate the report, right?
Yeah, basically it keeps the log of the execution flow, so it can automatically like generate the report, or it can generate the report based on the facts that it found in knowledge base, and you can exploit the target to the point the way you wish. You can actually like compromise just like a few border systems, or if you design like a propagation model, you can actually copy and start like running stuff from there and like try to collect the logs and stuff. Yeah.
And you can generate the report from the XML that was basically added by the tools.
Yep.
which will be easy.
Basically, all the facts are serializable in XML format. So what you can do, just like XML parser that will take the facts and generate like the reports in the format you want. Yep.
Okay, so that's going to put a lot of the penetration testing security companies out of business, and everything can be automated.
Well, we're trying to kick the security industry a bit to go on the way we think it should go. So it should focus more on the research and more on the things that actually make sense, instead of like making people like running stupid nmap execution things just because these people understand the result from the nmap, so they make you to interpret and like report what you see in the result of nmap without doing anything that is actually interesting for you personally. So this tool we just like give to people, go ahead, use it, and yeah, put the security companies out of the business. We don't care. Yeah. Any more questions? Yeah, then we would like to thank you a lot for your attention, and thanks for good questions. And yeah, thanks. Hope to see you online. But, yeah.